Here we're looking at the back of a BMW X5 with one of the inside rear taillights out, the one on the left. As you can see, this isn't a normal brake light, but it's housed inside the same compartment as the LED taillight. Sometimes these other lights are called adaptive brake lights, and they use a normal white bulb instead of a red LED. But for this video, we'll be focused only on the LED lights, which are not so easily replaceable unless you simply buy and swap out the whole taillight assembly. These are supposed to be long-term, if not lifetime parts, but sometimes something on the PCB goes out. And then unless you want to test parts and monkey around with repairing the board, you can simply just make your own custom red LED part and basically replace only the board for a couple of bucks. So in this case, I needed a quick fix. And if you do it right, it could even be semi-permanent. This is one way you could try and do it and get the job done quick and easy. We're going to skip some steps here to keep this shorter, and I'm going to assume that you know how to solder and hot glue and do some basic wiring work and stuff like that. This is really just to show that this sort of a quick, super cheap fix can be done, and even though it's not a super high quality fix, it does last for a good while. So to fix this taillight, we need to open the tailgate, and you're probably going to want to sit on this trunk door here off the back of the car, because it will take a while to do this. Note that this LED light is not housed in the same place as the reverse light or the side brake light. So you're going to want to grab a whole bunch of your go-to tools and have them handy. On the inside back of the tailgate, I'm just using a short flathead to pry open the housing that contains the interior trunk light and the stuff we're looking to access. I'm trying not to be too aggressive and break something, but after a bit of prying it for a while, a corner becomes free, and then I'm just using my hand to pull it the rest of the way off. Once we manage to open that, we can see where we need to access the bulbs and the LED light housing. Note that there are two sets of wires that are attached to the main bulb housing with connectors. You'll need to get at these to do any real work in here. To get this whole taillight assembly off the back of the tailgate, there's really just this one nut that you'll have to remove. I couldn't get a ratchet or even an extender in there with the right size socket, so I just decided to use a needle nose pliers. It's clearly not really the right tool for the job, but it did work for me, and eventually I got this nut off. Unlike a lot of things inside a BMW, this isn't a loose nut, so it's not going to fall off if you go too far. There's a little piece of plastic that retains this nut on there. And as you can see, once it finally comes off, it's all one piece that acts as a fastener to retain the whole taillight firmly in place in the back of the tailgate. Now I'm just feeling around the side of the light to see where there are a couple of tabs holding this light in place. This whole light will come off the back of the tailgate if you just pull it out toward the back and somewhat toward the side of the car. But the gasket tends to be a little stuck on here, so as you can see, I'm just using the same screwdriver to try and loosen it up from the back of the car. Again, not too hard because you don't want to crack the housing or scratch your car up. And once it's a little bit loose, you can see that I can pretty much just yank it off with one hand. These two connectors should initially still be attached to it, so you could just let it hang off the back while you loosen up the connectors, and then yank them off gently. They might be a little stuck in there, and you'll just need to wiggle them a little bit back and forth. You can see here how it looks without the tail light on there. If you run a multimeter off the main connector with two prongs, the one that used to be attached to only a red and black wire, then you can see that this usually reads about 14 volts if the alternator is running. At this point, it's pretty easy to go ahead and pull off the connectors and disassemble this unit into two parts. Now, when you look at the back of this whole taillight, you can see these plastic tabs and connecting pieces which are holding the actual LED circuit in place, with just a positive and negative wire coming off the green PCB, the printed circuit board. And this is what the PCB looks like after you extract it from the plastic housing. Now, to extract it, I would suggest that you don't try to pry the whole light assembly apart, because even though it may look possible to separate the red or white clearish plastic parts from the opaque ones, you're very likely to just crack or snap them with the pliers or a screwdriver. And then at that point, if you crack it, you may as well just buy a whole new assembly. So in my opinion, to get at the PCB, you need to carefully Dremel enough plastic away to be able to just pry it out. I've seen other YouTubes out there where they do this too. It's really more of an art than a science here, so I didn't add that part to the videos. You'll simply need to just use your best judgment and make sure that you can easily Gorilla Glue or epoxy it all back together afterwards. You can see how this PCB now just slides in and out easily. This may look different in your car. It's important to pay attention to clearances where it all comes back together. Probably best with some hot glue or whatever you want to use to make it all one piece again. So, there are options as far as what kind of foundation you want to use for your electronic parts. You can just use plastic from a milk jug if you want. This sort of plastic is HDPE, which has a low melting point and it will stick nicely to hot glue. And it's thin and flexible enough to make sure it will squeeze back into the PCB slot with a little wiggle room to reposition the LEDs a bit. And you can see me sizing it up against the PCB. The name of the game here is simply making sure that whatever bright LEDs you choose line up to exactly where the PCB LEDs are. And it's important to make sure it's thin enough that it won't be too big to slide into a space the same thickness as a PCB with surface-mounted electronics on there. It's important to mark everything carefully and lay it all out and test before you solder or glue anything together. The good thing about this is you can hot glue a couple layers together if you want, and the LED and resistor pins will go right through holes that you can easily cut out with an X-Acto knife. Now in this case, this is a redundant circuit, meaning that there are two pairs of LEDs. So while the LEDs themselves are pretty close together, there's a distance between the pairs, and we need to make sure we can hot glue a couple of wires onto this too. One thing I learned when I first tried this, I thought it might be okay to just use some ultra bright white LEDs since I already had lots of them, and they're going to be shining through a red piece of translucent glass anyway. But actually, that definitely won't work. It comes out a sort of amber color, no matter what I did. But playing around with this also allowed me to be certain of the thickness. Many of these usually round, typically 5mm LEDs, usually aren't bright enough for this sort of application, and furthermore, they're just sometimes a little bit too thick. So they make this part just a little too wide to fit in the slot. And if we tried to go for something like surface-mounted LEDs, I think that's just a little bit too much trouble for a little project like this. You can see another option here is a little piece of perf board, which already has holes already drilled to the right distances for LEDs and other electronic parts, but I found I needed a little bit more flexibility to really get it to fit into place. And as far as modern LEDs, there is something in between the surface-mounted ones and the super thick rounded ones. There are now lots of different types of ultra-bright, low-profile red LEDs that are perfect for this application. First of all, because each one only costs a few tens of cents, making the whole project only a couple dollars, but also because they're easy to solder and squarish with long, robust legs to solder to. This kind, I believe it was called Piranha Superflux red LEDs, are even advertised as ideal for brake light applications, so you know they're going to be good for this job. These LEDs have a forward voltage of about 2 volts, and we're aiming for a 12-volt system that sometimes spikes to 14 or even a little bit more than that. So we need a resistor, and in this case, if we aim for like 13 volts, we'd use around a 300 ohm resistor. And it's probably best to go for at least a 1/4 watt resistor, which you can get by doubling up a couple typical 1/8 watt resistors. This is a diagram of the sort of LED that I used, so be sure to check the specs, including the polarity of your own LEDs when making your own part. LEDs burn out easily with current spikes, and these things only run with the right polarity, so polarity is obviously pretty important. Now, in all honesty, the PCBs from the manufacturer have capacitors, a 12-volt voltage regulator for protection against power inconsistency, and resistors with redundancy. But since this is just a quick fix, I'm just going to use a single resistor and put these 4 LEDs in series. I'm going to guess that this will be good enough just to see if this works for a while. Now, to test out my design, I'm using an Arduino Uno, which are great for blinking the LEDs so you can see the brightness better. And unlike a direct connection to a battery, an Uno is not likely to just burn out your LEDs. You can see that when I just wire up my test design with alligator clips, it works just great. And when I compare that to the other working taillight on the car, it seems to be just about the same brightness, or at least close enough. So once I soldered up the final design together on a little piece of milk jug plastic, and then hot glued it to make it more steady and a little waterproof, you can see that it works just fine, and it's a nice small little piece that fits perfectly into this Dremel hole, up against the clear plastic piece on the inside that spreads the light a little bit like fiber optics. And then I put the whole thing into a clear plastic bag just to give it a bit more protection from the weather. And after installing everything back the same way and splicing it into the old connector that I cut off the old PCB, you can see that this taillight turns back on again. You can go back in there and reposition the LED until it's perfect. It may not seem exactly the same brightness here, but that's due to the angle. In real life, you can't see any difference. And it's been around 3 months now since this fix was installed, with plenty of snow and rain in the meantime, and it's still working just fine. I'll probably have to replace it at some point, but for now it works just great. Please be safe when you do this sort of work, and make sure to pay attention to the laws in your area about brake lights and brake light repairs. Hope this was helpful. Thanks for watching, and be sure to like and subscribe.